every system that has modules and pieces of the system separated into smaller pieces are going to have dependencies. And I'm not going to try to uh, educate you here about dependency injection, other than the fact that Glee2 definitely tries to adhere to the solid principles, one of which is dependency inversion principle, which basically, I'm not going to try to define that, but it's basically saying that we should be inverting the control of those dependencies. We should be injecting those dependencies somehow so that lower level modules don't depend on concrete versions of systems. Instead, they should depend on abstractions like interfaces. So when we have a constructor, for instance, we would definitely prefer to inject our dependencies like our database and email senders and all kinds of things. Whatever we consider as a separate module or dependency or a service, we would like to inject those into the constructor of our controllers so that those controllers don't carry, they're not tightly coupled to the implementation of those things. So, for instance, if I'm going to send an email in a controller, which I probably wouldn't do, but just for the sake of example, if I have a controller that's going to send an email, then I would ideally be injecting an I email sender, some sort of abstraction of an email sender into the constructor, and then at runtime, the system, the bootstrapper, should go out and find the most appropriate implementation of that I email sender and inject the real concrete thing into the constructor at runtime. But at development time, all I know about is it's an I email sender, and that's all I should have to care about. So this can get pretty hairy, especially if you're thinking about, okay, how do we systematically instantiate new constructors at runtime based on the request for every request. So the request comes in, and we based on the route, we know that we want to go to the employee's controller, and we find the right method. But in order to get to that method, we have to get an instance of that controller. Let me get into the code, and we'll be able to walk through it just a little bit more. So we find the route that is appropriate, and we find that we need to get into the employee constructor. So for that request, ASP.NET ASP.NET Core is going to instantiate this employee's controller, and is going to eventually direct us to the right method to handle the route. But you see here, in order to do that, we are injecting our dependencies. We got 4 dependencies here. We got a command dispatcher, a read-only repository, a mapper, and an identity generator. And so we need to have real instances, concrete instances of each one of those things at runtime. The way to do that, one way to do that, is to instantiate all of those things ahead of time and have them ready. But that would get really crazy. I mean, you would have to, let me just see if I can do that here kind of in pseudocode. You would have to say new employee controller. My keyboard's not working. New employee controller, and then you'd have to pass in, whoa, I'm not spelling it right. Employee controller, and I would have to pass in a new command dispatcher. You could do that here, but then that's going to have dependencies. So I'm going to have to turn in a list of. You see, this rabbit hole is getting deeper and deeper, and if I kept on typing here, you would see that we would end up with a massive block of code with all the dependencies defined and instantiated. But that's me doing it manually. What we What we really need is to be able to do this kind of automatically, and we need something to maintain our dependencies for us. And that's where an IOC container comes in, or an inversion of control, or a dependency injection container, sometimes people will call it. And ASP.NET Core makes that actually pretty transparent, or pretty invisible to the developers. I don't even know if most developers these days know even that you would normally call that a container. And you may not even realize that there is this IOC thing going on under the covers. I think most developers these days, if you've got any experience with ASP.NET Core, or even latest versions of MVC and Web API, you just register dependencies, or you just set up automatic scanning, and then they just automatically magically get injected at runtime, and that's fine. But I'm trying to give you a little bit of history about what it's actually doing under the covers. So so we are injecting our dependencies here. How does ASP.NET Core know to replace this I command dispatcher with the worker command dispatcher at runtime? And I actually have another thing going on. There's a validated command dispatcher that uses the decorator pattern, is actually going to validate the commands before they dispatch. And so there's actually two command dispatchers going at the same time that need to be injected here. And how does the ASP.NET Core bootstrapper know that that's the one that it should do? Same thing here with the read-only repository. This repository, the concrete class of this concrete version, has also a dependency on the database context, that entity framework database context. One of those contexts needs to be one of those things needs to be scoped to the request. Meaning it should have one instance for the request. Every time it asks for a new instance, it should give it the same one for that request. Another thing in our system should be using the singleton pattern. So it should actually create one instance for the entire life of the application, because there's no need to reinstantiate every time. Other things need to be transient. We need to have a brand new instance every single time we request one. So those kinds of things are not easily controlled right here. If I were to try to do this manually, but ASP.NET Core makes all those things very possible, so that while we're coding this constructor, we don't have to worry about any of that. Really, we just have to trust that there is an identity generator here, and that we can call generate, and that it will give us an ID. Same thing with the dispatcher. We trust that at runtime we have a command dispatcher that we can call dispatch on, and trust that when we dispatch this command, something good is going to happen. So let's take a look at the bootstrapper to understand a little bit more what's going on and how this works. So let's go into the infrastructure folder, and I have here the bootstrapping folder. And now here we have all of our bootstrapper extension methods and classes, which, if you don't know what's going on here, you should take a look at the video, the Glee2 video about the startup. So let's take a look at this dependency bootstrapper. Now we have one bootstrapper class that is actually using three different extension methods to handle three different areas of dependencies. One, the data dependencies, the other is the web dependencies, and the other is auxiliary services. So let's take a look at the bottom first. We've got two different auxiliary services that are being set up as singletons. These singletons, as I said before, a singleton is going to have one instance for the entire life of the application. Meaning when we press play, when we start the application, it's actually going to start one instance each of these singletons, keep them in memory, and every time anything in the application asks for an identity generator of type GUID, it's going to give it this exact instance every single time. Same thing with the API information getter. It's got a default implementation that it's going to instantiate it one time, and it'll never instantiate it again until the application is started again another day. The reason why these are good for singletons is because they're not doing any kind of input output. So if I were to go into this, you can see that this is getting information about the assembly. It's really, I mean, it's just doing some reflection. It's looking at the assembly. It's looking at itself basically, and it's returning this file version. After this is done, after this is instantiated one time, it really never needs to be instantiated again. In fact, this class could be a static class, but then it would be harder to inject. So let's take a look at the other one. There's this GUID. This again is another instance where this could be a static class, a static function, but it would be a little bit harder to inject. And you never know. This could become something that is a little bit more complicated later on, and it might be good that it's an instance class. But in this case, we don't really need multiple instances of this. We don't need to pay the cost of instantiating this over and over and over. So this is fine to be a singleton. On the other hand, there are other things that are better to be scoped in a certain scope. And in this case, I'll go back up to the top. These two services are actually being scoped at the request level. So when a new API request comes into the server, it will, and then something requests these exact these interfaces, this iRead-only and iWritable repository. When it requests those, a new API request just came in, it will create the instance for the first time, and then throughout the lifetime of that API request until the response is returned to the user, every time anything asks for a repository, it will give it that same repository as the first one that it requested, that it instantiated at the beginning of the request. So if in the lifetime of a request, which could last half a second, maybe 10 times, 10 different things ask for, hey, I need a repository. Hey, I need a repository. The first time it'll instantiate it. The second time it'll reuse the one from memory. Third time, memory. Fourth time, memory. All the way until the request is finished. So that is what it means by scoped. It's scoped to the lifetime of the request. So these two things are good to have as scoped to the lifetime of the request, because there may be some state that's necessary that from request to request, from use to use during that request, that it may need to share. So that's why these are good to have as one thing. As far as web dependencies go, here's another instance of the singleton lifetime, but this is a slightly different implementation, and so I'll explain what's going on here. And this is something that you can also do with your own classes if you are going to be using like the strategy pattern, and you want to be able to inject a list of things, of strategies. That's kind of what's going on here. This iException render is kind of like a strategy. And so there are several implementations of this interface. And so what we want to do is we want to scan from the assembly that contains this guy right here, which is going to end up being this same exact assembly, the web assembly. Then it's going to add any classes that are assignable to that interface. See how that reads? So that means that anything that implements this that is inside of the web assembly, it's going to add it, and then it's going to associate it with its implemented interface, which means, let me give you a better example. I'll show you over here in the folder tree. I've got this renderers folder. I've got a bad request renderer, and I've got a validation renderer. And I've got the interface for them. So I've got these two renderers currently. You may have more because you may have created more. What this does is it's going to scan the web assembly, and it's going to find all the implementations of this exception renderer, which are these two. Then it's going to basically do this. It's almost the same as if you are manually saying services.add singleton iException renderer for the first section of that, and then for the second section you would say bad request renderer, and then have another line of add services, services add singleton iException renderer, comma validation renderer. And by doing those manually, it's the same thing as having this scan logic right here. But what's nice about this scan is that it is allowing us to not have to manually do these. Let's just imagine that over the course of your application, you end up creating 10 more of these renderers. It would be a huge pain in the neck to have to come in here and remember every single time to manually register each exception renderer as you implement them. This way, all you got to do is create it, and by virtue of existing and implementing this interface, it automatically gets pulled into this registry of dependencies. So that when something out there calls for a list of iException renderers, it'll just automatically go in there and you don't have to manually register it. Here is actually where that is being injected. So this class is going to be instantiated using ASP.NET Core's IOC container, and it's going to automatically inject that both of these two renderers in this constructor. So then when at runtime, if you were to put a breakpoint here, if you at runtime, you would see that this renders argument has two renderers, these two renderers in it. There are a few other things that you may need to be able to do with the dependency injection in ASP.NET Core, and I'm going to call that out of scope for this video because at this point I really just want to show you where to find the stuff and give you a light touch of training on how it works in ASP.NET Core, and then also to pique your curiosity because you can also very easily go into Google and search for these things for yourself. But for now, I think you should have enough information to get you going, and I hope you have a great day.